Let's begin by drawing a label diagram. That's the ladder, that's the wall, and that's the ground. So we have normal reaction at the wall, which I'm going to call Ry because the ladder is called XY. Okay, so the reaction on the ground I will call Rx. We also have friction on the ground because I don't know which way to draw it for now. I'm going to draw it this way, but it's rough ground, that's why we have friction. But because it's a smooth wall, we have no friction at the top of the ladder. We also have weight. Because it's a uniform ladder, I have to draw the weight exactly halfway along. So I'm going to call this half L and this half L. The angle is just theta for now. They've told me tan theta is √3. And then we also have a push force because we have an assistant at the bottom pushing to stop it sliding. And then we've also got somebody standing at the top with weight 9W. Okay, so now we've labelled everything, let's answer the question. It says work out the reaction of the wall on the ladder at Y. So we need to work out Ry. And I think the best thing to do is to take moments from X because then that will eliminate P, Rx and F from my equation. So that's what I'm going to do. Moments about X. Right, so we have a clockwise moment of L/2 cos theta times W. We also have a clockwise moment of L, if I look at the big triangle, cos theta times 9W. And then we have Ry pointing horizontally, not vertically. So I know that I'm going to have to look at this perpendicular distance, which means I've got to use sine. And that goes anti-clockwise, so I'll put it on the other side of the equation. Right, if I divide everything by L cos, that will cancel the cos there, and then this will change to tan, and then my L's also disappear. So this equation, if I write it simplified, is going to be W/2 plus 9W equals Ry times tan theta. And that's useful because I know that tan theta equals √3. So if I put the fraction together on the left-hand side, I'm going to have 19W/2 equals Ry √3, and then you've just got to divide the √3 over, so you get Ry equals 19W/2 √3, and that's part A done. Okay, part B says find the range of possible values of P for which the ladder remains in equilibrium. Now, if that window cleaner's assistant is pushing quite hard on the bottom of the ladder, then you could say the ladder is about to slip up. So then you'd expect friction to go to the left. So let me write that down here. So if P is quite strong, if it's quite a strong push force, then you expect friction to go this way because the person's almost pushing it up. If P is quite weak, so it's not a very strong push force, then you'd expect friction to go the way that I've pointed because it would still tend to slip down. So you would expect friction to point to the right. Now, bearing that in mind, so knowing that in each of these cases it's not actually moving, it'd be on the verge of moving, or in limiting equilibrium, then we can work out the range of possible values that P can be. So first of all, let's work out F by doing mu Rx. What's Rx? So let's resolve vertically to get Rx, because Rx is pointing vertically. We've got Rx equals, and then downwards W, add 9W. So Rx equals W plus 9W, which is 10W. Now if I sub that in here, and I also know that mu is 1 over 5, it says in the question, then that means F equals 1 over 5 times 10W, which is 2W. Okay, so that's F. Now, to get the minimum value of P, we're saying that F is pointing the same direction as P. So resolving this way, horizontally, I've got P plus F is Ry. So P is Ry, take away F. And if I put my values for that in, so we worked out Ry in part A, 19W over 2 root 3, take away the F that I just worked out. That's going to be my minimum value of P. Let's take W out. Okay, so to get my maximum value of P, we're saying that F has to be pointing left. So if I resolve this way, I'm going to have P minus F equals Ry. So we've got P equals Ry plus F, which is 19W over 2 root 3 plus 2W. And then again, I'll just take out the W. Right, so that is the maximum value of P here, and the green one is the minimum value of P. So what's the range of values that P can be? We need to write it as an inequality. So we say 19 over 2 root 3 minus 2 is the minimum, and P can be in between that value and also the maximum value. And also including those values. Okay, so what's part C? It says, explain how you've used the fact that the ladder is uniform. Well, what we've done is we've said that the weight acts at the midpoint of the rod. And part D, it's got part I and part 2I. It says, if you actually said that it was non-uniform and the ladder is wider and heavier at the bottom, that means the center of mass would not be here, it would be a bit closer to the bottom. So if I just show it on the diagram, what you're saying is W is actually, say, here. Now, if that was true, what effect would it have on Ry, which is the reaction at Y, and the range of values for P? Now, if you've got the weight acting closer to the bottom rather than the middle, hopefully you can see that that would take the pressure off the wall. So that means that you'd expect Ry to be smaller. So I'm just going to write that down. Ry would decrease. Now, what effect would that have on the range of values for P that you just wrote here? Well, if Ry is smaller, because this represents Ry, so does this, then the range of values for P will also be smaller. So I'll just write that range for P would also decrease.